Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of projections. So as per the problem, determine the scalar and vector projections of vector A on each of the three axes. So first we'll have to write a vector for the three axes. So let's start with the x-axis. So we can use position vector of a point that lies on the x-axis. It can be any point on the x-axis, but it will be easiest to work with 1. So we can use the position vector for point 1, 0, 0, which is equal to 1, 0, 0. We are calculating the projection on the x-axis. So length of vector that we use for x-axis won't matter. The answer will be the same for all position vectors. Similarly, for y-axis, we can use the vector 0, 1, 0. And for z-axis, we can use the vector 0, 0, 1. So let's start with the scalar projection for x-axis. So I'll write SP for scalar projection. So this is the formula for scalar projection. Now we can use the given vector A. In the denominator, we can write the expression for magnitude of vector x by squaring the components of vector x, adding them, and applying square root to the sum. Now we can do the dot product in the numerator. The negative 1 times 1 is negative 1, 2 times 0 is 0, 4 times 0 is 0, and in the denominator we get 1. Scalar projection is equal to negative 1. Now we can find the vector projection on x-axis. So we can start by writing the formula. Now we can sub in the vectors. The magnitude of vector x is 1. Now we can simplify this expression. So for the dot product, we got negative 1 in the calculation for scalar projection. Now we can do the scalar multiplication. So we'll multiply the vector by negative 1. So we multiply each component by negative 1. So this is the vector projection on x-axis. Now we can do the calculation for y-axis. So let's start with scalar projection. Now we can do the dot product in the numerator. So we'll multiply the x, y, and z components. So negative 1 times 0 is 0, 2 times 1 is 2, and 4 times 0 is 0. So I got 2. So this is the scalar projection of vector A on y-axis. Now we can calculate the vector projection. The magnitude of vector y is 1. So for the dot product, we got 2 in the calculations for scalar projection. Now we can do the scalar multiplication. So we'll multiply each component by 2. So this is the vector projection on y-axis. Now we can do the calculation for z-axis. So let's start with the scalar projection. Now we can do the dot product in the numerator. So we multiply the x, y, and z components. So negative 1 times 0 is 0, 2 times 0 is 0, 4 times 1 is 4, and in the denominator we get 1. So the scalar projection on z-axis is equal to 4. Now we can calculate the vector projection on z-axis. The magnitude of vector z is 1. The dot product in the numerator is equal to 4. Now we can do this scalar multiplication. So 4 times the vector 0, 0, 1 is equal to 0, 0, 4. So this is the vector projection for vector A on z-axis. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.